Autodesk Inventor and Fusion 360. Right, I talked up, I don't know which other direction it is, about the two programs and how they're different and who they're traditionally targeted at. But one of the biggest mysteries to many is, but what exactly does Inventor do that Fusion can't at an actual feature level? Like, what's Inventor better at? Well, a quick disclaimer, unless you've got 3 days, mate, I can't go over them all here. So these are my top picks of 15 features that Inventor does that Fusion 360 doesn't today, because the Fusion team could add any of these features into Fusion 360 at any point in the near or distant future. So, my life. But if you've got a bit of a surreptitious fondness for videos like this, right, infotainment, do get subscribed, because coming soon will be the flip side of this video, looking at what Fusion's got that Inventor lacks. Subscribe button's just down there, Dave. Yes, Dave, thank you very much. It's next to the join button. That's a tempting one too. It's down there. Thank you so much. Kindly. Great. In no particular order. Number 1, referencing driven dimensions. Yeah. Is this something that a lot of Inventor users just will take for granted because you've just been able to do it since Cat was a kitten? But in Fusion 360, due to the way they've built the sketching architecture from very early days, you just can't do it. Well, you can reference a driven dimension if it's in the same sketch, but in Inventor, you can create an entire sketch full of driven dimensions, set them as named parameters, and then reference them throughout the entire design. In fact, in Inventor, you can even reference driven dimensions across into completely independent different part files as linked parameters. You can build an entire part of driven dimensions like a skeletal model and link it into different parts. Number 2, superior 3D sketching. So, yeah, Fusion 360 does have a 3D sketching environment, which actually fundamentally works very similar to Inventor at actually laying down the sketch lines. Inventor just takes Fusion to the actual cleaners from there on, because for reasons that I've yet to kind of figure out, Fusion seems insistent that you need to reference your 3D sketch to a 2D plane. Well, I don't, never mind. Inventor, though, 3D sketches are completely space agnostic, and they've got their own dedicated contextual environment. From there, Inventor just packs an absolute ton of dedicated features, which makes 3D sketching far more powerful than within Fusion 360. So, for example, in Inventor, you've got Curve on Face within 3D sketching. It's an absolutely incredible tool that makes for some insanely creative sweep or pattern paths, alongside a couple of properly matured projection methods, letting you take 2D profiles and then correctly throwing them onto literally any surface, with one of my personal favorites being the ability to take an open loop curve like this one here and then just wrap the entire thing around a face pretty much one-to-one. Absolutely love that one. Number 3, and I delivered this one with my absolute deepest heartfelt condolences to all Fusion 360 users. I mean, come on, Autodesk. Seriously, it's 2022. Even the program that I used to write this script has a dark theme. Yep, it took them long enough, but Inventor has a dark theme. Well, sort of. What's this? I don't know, but I'll take it. It's better than what Fusion's got. Number 4, drawings. Now, Fusion's getting better, but Inventor Inventor's there. And where it excels is in the granular styles management, the finer details that you kind of don't appreciate until you really need to call upon them. Like, for example, layer control. Inventor was developed and grown during a time when the world was rapidly progressing from 2D to 3D, right? That boom, AutoCAD to Inventor. And people were used to managing the data on layers, objects on layers, because they just worked. That's what AutoCAD used, and it all made sense. All entities on an Inventor drawing are automatically placed onto default layers, and you can put any line you want onto a different layer. You can change any layer's name. You can change the properties of the layer. You can even manually define custom line thicknesses to any thickness you want, which you can't do in Fusion 360. Inventor also has a unique view type called overlay views, which allows you to show an assembly in an alternate positional state overlaid on top of itself. Think of this as like if you've got an engine thruster opening and closing, or a crane in a raised or a lowered position. And this list, it's far from extensive, but Inventor also allows for true isometric view linear dimensions, something Fusion 360 is still unable to do. Number 5, probably one of Inventor's strongest feature sets. Its design accelerators. Now, Autodesk Inventor has an absolutely incredible collection of engineering-centric tool sets for the automation of the creation of many common mechanisms found within mechanical and structural design, such as spur, worm, and bevel gear generators, which alongside power transmission calculations will physically model accurate toothed cogs and gears, which then even drive themselves, rotate in position, and animate themselves. There's a modular shaft generator, there's ball bearing designs, there's compression springs, there's pulleys, belts, roller chains, a full bolted connection compiler that puts together a bolt, a washer, and a nut from countless international standards, along with stress and fatigue checks on the connection. Few of these measure up to the absolute power and the utility of the Autodesk Inventor frame generator. Now, I made a full end-to-end tutorial on this myself several years ago, so feel free to check that out if you get some time and you want to know some more. But essentially, Inventor has a massive library of international standard profiles which can be placed against a skeletal edge or edges. Inventor then auto-generates frame member solids or parts, itemizes them all up for cutting or parts lists, and you then got, mate, a pretty decent arsenal of treatment tools for mitering corners, trimming frames, notching. You can even drop on end caps onto the frames. This can all be then pushed over into the beam analysis simulation environment for load testing. Now, I'll give the Fusion users a moment to grab a hanky whilst I proceed with the next, because underpinning a lot of number 5 is number 6, the Inventor Content Center. This is often misunderstood, even by Inventor users themselves, because many think it's just this big, huge folder somewhere on the system or a big zip file full of models. Quite the opposite, actually. The Inventor Content Center, it's an absolutely ginormous database of standard part definitions. Think of it like a massive Excel spreadsheet, with each row being a potential bolt or a nut or a washer or a pin, rivet, and each column being the necessary dimension for the sketches and features required to actually create these models. When you do want one, all you have to do, mate, is say place from the content center, tell Inventor which size you want. It then looks that row up from the spreadsheet, models the part for you within like fractions of a second, and then drops it into your project. Pro users can then go one level higher by creating their own custom company content center libraries, publishing either different sizes of nuts, bolts, and washers into the database if they want additional custom sizes, right? They can then add their own metadata into the libraries, like their own company part numbers, or you can even add their own standard profiles or parts in from scratch. And a very closely related sibling of number 6, number 7, configurable family parts, formerly known as iParts, now known as model states. So with Inventor, any model that you create can be leveraged into having multiple variations of itself driven by parameters. Think of a basic disk. It's simple. Think of a disk, right? Manufactured with 3 holes in it. But the same disk can be made with 4, 5, 6, 7, or 8 holes. So you can use Excel if you want to, right, to help you accelerate the process. You can create all the different states, all the model states. And then what you end up with is one master part with multiple possibilities. Inventor then has all this covered downstream as well. Place the master part into an assembly or a drawing, and that's going to then offer up the option of using one of the many different possible model states for placement into the assembly or the drawing. And if all that got the Fusion users tearing up, mate, you might want to go grab the hanky box and go fetal under the duvet, because number 8 is assemblies. Yeah, all right. Look, it's common knowledge, and I'm not going to dig it in further, that Fusion 360 struggles with heavy data sets. If you want to see a prime example of this, mate, the video's 4 years old, but this video here pretty much perfectly encapsulates the large assembly issue, with Autodesk themselves in this video confirming that someone had hit limits with the Fusion 360 platform. But again, that was 4 years ago. But over and above that, Inventor obviously runs rings around Fusion when it comes to the construction of not just large, but also just the handling of smaller assembly datasets. It offers a wider array of management tools like assembly component replace. So if you've got a part that you want to just quickly swap out in your assembly with another part that you've got, it might be the same part or a completely different one. Inventor will use component replace. It'll go grab another part and just switch them over. Component promote and demote as well. These are notable additions to Inventor, enabling you to take a collection of parts in the browser and in one click either demote them into their own new subassembly or promote them out of their current subassembly and push them up a level whilst impressively retaining all the assembly constraints. Speaking of which, assembly constraints. So Inventor has joints as well, right, for trying to piece parts together whilst building in mechanical intent and all that. That's all Fusion's got, right? Joints. It's probably just, I'm hoping it's just me, but I have absolutely no idea what the frig's going on with Fusion 360 and its joints. I take this subassembly here, this oil cover. I want to position this whole thing over here. Why the hell is it only moving one of the parts? Why is it like this? If there's a workflow that I'm missing that will move the whole subassembly, which is obviously what I want to do, that needs to be the default workflow. Anyway, doesn't matter. Inventor, it just does stuff like this far better, because in addition to a bunch of mechanical style joints, it's got its constraints. Simple, good old constraints. Just pick a face, pick another, and then clunk. You want to define an angle between two objects? Need bother, mate. You want two surfaces permanently tangent? You got it. Need an object to be constrained along an uneven surface, and then want to slide along it? Fill your boots, mate. But potentially dipping into the realms here of subjectiveness, I find Inventor, me personally, to be immeasurably better at contextual level awareness when it comes to the assembly browser. The reason I say that is because it took me a while to sort of put my finger on why, when I was using Fusion 360, why I felt so sort of uneasy, agitated, and a bit angry. And ultimately, I realized it was the dreadful model browser. Like, look at this. Aside from the inactive component transparency levels being kind of, I don't know, maybe just too strong for my liking compared to Inventor, where am I working, right? I mean, and what I mean by that is like at what level in the tree? Where is the part? Fusion doesn't jump to the part when you activate it, and only whilst it's highlighted does it put this really weak, weird, easy to miss squiggle. It's really frustrating. Inventor, exponentially better. The second you edit a component, the browser changes context, goes straight to the part in the tree, and it makes it blindingly obvious what you're editing, and everything else is completely out of context. Inventor also appreciates the fact that the browser can get really messy, mate, so they introduced browser folders. This allows users to create custom named folders which are completely independent to any and all assembly relationships. But lets you group together similar items like bolts, or even items that are in a certain product family. Create as many browser folders as you want, call them whatever you want, and it keeps your browser nice and tidy. Numero 9. Now, something a little lighter. Bend part. Fusion users be like, wait, no, right. We got this. We can do that. No, yeah, yes, but right. In Inventor, bend part it's available to literally any part in any state, and it's tremendous. Simply smack a sketch on a face, draw a line, and Inventor will bend the model around the line to the angle and radius of your choosing. Fusion does have something similar, but it's strictly limited to sheet metal parts, meaning you have to mess about with sheet metal styles to get it to do what you want, which, mate, it's just not the same. And that leads me also on to number 10. Yeah, sheet metal. Fusion 360's sheet metal is, not to put too fine a point on it, it's absolute hee-haw, mate. Hee-haw compared to Inventor it is. And for a product claiming to be sort of hardcore manufacturing, it's hee-haw. It works, you can get stuff done in it, it's just lacking a lot. Inventor, for example, it's got the best named command ever, rip. So say you've got a lofted flange, right, squared around. In Fusion, you'd have to meticulously trim out a section of both sketches or else the damn thing just won't unfold because it's going to be one completely closed, fused body. And how much do you trim out? How much do you open up, right, for it to properly? I don't know. It's a chore. No problem with Inventor though. Just pick a point and rip the f*** wide open. Now that's your parting line now for unfolding a flat pattern. It's also got the hem command in Inventor for creating intricate rolled finished edging. It's got contour roll, which is one of my all-time favorites in sheet metal because I'm just weird like that. But you can either wrap or revolve a sketch line into a flat patternable sheet metal product, or you can take an existing profile and roll it around an axis like this. how good's that? And then you've got the oddly named sheet metal bend, which has got absolutely nothing to do with the Fusion 360 sheet metal bend or the Mate, it's like I have no idea why they called it that. But it's friggin' awesome. But speaking of awesome, number 11, a fairly recent addition to Inventor, Solid Sweep. It's so good. I actually used Solid Sweep during the InvMark modeling test because it's multi-threaded. But anywho, Solid Sweep. It's basically an iteration of regular sweep, obviously, but it lets you sweep solid bodies along a path for either creating material or cutting away material, whatever your reason. In an Autodesk Inventor, you got it as an option. Number 12, Pack and Go. One of those things that tons of Inventor users either don't even know that it's there, don't know they've got it, or they don't know why they need to use it. But think of Pack and Go as like a total complete project compiler. It looks at your active design or your entire project, and it goes and grabs everything. All the referenced children, all the child parts, all the drawings included, all the custom entities like linked documents, and it zips them all up into a transmission package, aka a zip file. And then you can tell it to dump everything into either a single folder within that zip file, right? So it just goes through all your folders and then extracts everything or zips everything up into a single folder. Or you can tell it to retain your original project folder directory structure. Then what you end up doing with that resulting zip file is entirely up to you. Number 13. And if you thought I'd kind of peaked, or I would have started with all the good ones, and now I'm kind of struggling, no, because 13's iLogic. And contrary to this really confusingly inaccurate Autodesk AKN article, Fusion does not actually have iLogic. I don't know what the hell that's about. Right, this is iLogic's something that annoyingly I just can't do, even though literally everyone keeps asking me for tutorials on iLogic on my channel. But iLogic is essentially custom automation for designs, which really doesn't do it any justice. So with iLogic, you create code snippets to automate almost anything. The creation of drawings. You can automate repetitive tasks in Autodesk Inventor. You can automate metadata creation. You can create visual forms with product configurators and then build, model the design through automation. It's essentially rules-based design through automation. It's based on VB.net. And contrary to what anyone says, and I will violently argue with anyone who says otherwise, because they did back in the day. I remember vividly when Logmetrics was bought by Autodesk. You absolutely do need to understand programming language to use iLogic. Yes, you do. You do need to be a programmer to use iLogic. It's all about if this, then that, else if, do this, that, and the other. It's within anyone's capability to learn iLogic and to learn programming. And you can do that, mate, through some of the world's best training content on Pluralsight. # sponsored link in the description. If you've got the time, I just don't, and I never have had the time, but there's no denying iLogic, when done right, when delivered properly, it's one of Inventor's major trump cards. All right, look, I already have an absolute shit ton of editing to do on this video. I've given myself so much work to do with this, but it's kind of doing my head in, leaving it at 13. So number 14, Positional Representations. Yeah, Inventor can create assembly configurations known as Positional Representations or POSReps. Remember overlay views from the drawing bit? Well, this is what drives those. They're quite simple, really. Each POSRep is a saved state of constraints at different values. One POSRep could be, I don't know, an assembly with an angle constraint set at 0 degrees. The next positional rep is the same assembly with the same angle constraint set at 90 degrees. But the end result is what that constraint change does to the actual model. It could represent real-world movement or real-world position change, and it saves those as positional representations. Number 15, lastly, maybe probably too big to just kind of throw in at the end like this, but model states. Model states in general, and simplification tools. Look, Fusion has simplified tools, but I mean, please, they're shit. Inventor's assembly model states, which were formerly known as levels of detail, these let you take an assembly, suppress or hide parts that you don't want as part of that state, and then save that as a named state, which then each state can have its own bill of materials. And these have been historically used for managing big data sets, heavy data sets, right? Say you've got a vehicle with like 50 or whatever thousand parts in it. To quicken up the loading times, right, you can create a model state, suppress thousands of parts, the nuts, bolts, and washers that you don't want to see. And then you just open the data set straight up to that model state that's got all of those little mini parts all suppressed out. The way Inventor works is that all the suppressed parts, they're not loaded into RAM, so you can make all the large assemblies easier to work with. Inventor's simplified tools, which work hand in hand with model states, well, they're a lot more sophisticated than Fusion 360's simplified tools. You've got more control over what gets simplified. The bounding boxes can be based on conditions, and ultimately the end result, the file that's created as a simplified variation of the original design, that's linked back to the original design. It can also be nested in as a model state, so you can configure or flip between showing as a subassembly the simplified design or the original subassembly. And they're all linked. Subassembly updates, the linked simplified part will update to suit. Okay, right, really that is enough. But don't be rushing down to the comments to be typing out today white knight and defending Fusion, like, oh, you know, Fusion's got this, that, and the other. Look, Fusion's going to have its moment in the sun. I'm planning a video showing what Fusion can do that Inventor doesn't. Fusion's got tons of stuff, mate. It's amazing in its own merit. So yeah, that's coming. But yeah, the point here isn't to beat on Fusion. That's generally not what this is. If anything, the point of this video is just to let Fusion users know kind of what Inventor has for the price tag, I guess. Like why that would be an upgrade path. Yeah, on the flip side, the Fusion video will let Inventor users know why Fusion could be used in addition to using Autodesk Inventor. So yeah, I'm going to leave it there. Don't forget, Dave, subscribe. The button's just down there. Don't forget, it's next to the join button. I've got so many screen grabs to take and videos to make showing the function. I better get a flipping wriggle on. Right, all right, thanks for watching again, and I'll see you in the next one. Noodles.